This is Section 2, Solving Systems by Substitution. Our objectives are to solve systems of linear equations in two variables by the substitution method, and use substitution to reduce the system to just one equation with only one variable. Sometimes it is difficult to identify the exact solution to a system by the graphing method. In such cases, you can use a method called substitution. The substitution method provides an algebraic way for calculating precise values to the solution of a linear system. Here are the guidelines we'll be using to solve by substitution. First, we want to solve for one of the variables in at least one equation, if that's even necessary. Sometimes the equations are already solved for a variable, and sometimes they're not, and we have that first step. Step 2, substitute the resulting expression into the other equation. Step 3, solve the equation to get the value of your first variable. Step 4, substitute that value into one of the original equations and solve. And step 5, express your final answer as an ordered pair, x, y in parentheses, and check that it makes both equations true. Here's example 1. Solve the following system using the substitution method. We see that the equations are already solved for y. So anywhere I see y, I can take 2x and plug it into the other equation for y. This gives me my new equation. (2x) is equal to x plus 5. Notice I use parentheses whenever I do a substitution. That means that it replaced something else that was there. Now I'll take the parentheses away so I can simplify. We can subtract x from both sides to combine like terms. We get x is equal to 5. Now, if we go back to the original system, I can plug in x equal to 5 into both equations, and both equations must give me the same value for y if this solution is correct. So in the top equation, we see y is equal to 2 times x, but x is 5, so that gives us y is 10. And in the second equation, we see that y is equal to x plus 5. Since x is 5, 5 plus 5 gives us 10. Because we have a match, we are confident our solution is correct, and we can express our solution as an ordered pair. And we're done with example 1. Okay, so here is example 2, and notice that neither of these equations is solved for x or y. Nothing is in x equals form, nothing is in y equals form. So we can solve one of the equations for x, or we can solve one of the equations for y. I'm looking at the second equation because there is only a -1 in front of x. There's not a number like 2 or 3 that I'd have to divide everything by. So I'm going to solve equation 2 for x. So 3y minus x equals 7. I am going to add x to both sides. That gives me 3y equals 7 plus x. Now I am going to subtract 7 from both sides. 3y minus 7 is equal to x. This means that I can take 3y minus 7 and plug it in for x in the other equation. So now we will write our new equation. We said there's a 3 times x, but I'm going to replace x with 3y minus 7. I'm using parentheses to show that I just did a substitution of the variable, plus 2y equals 1. Now we can use the distributive property to multiply 3 through the parentheses. That gives us 9y minus 21 plus 2y equals 1. We can combine the y's together. That gives us 11y minus 21 equals 1. Add 21 to both sides, and we have 11y equals 22. Divide both sides by 11, and we have y equals 2. I want to take this y equals 2 and plug it into our original system. So we had 3x plus 2y equals 1, and we had 3y minus x equals 7. We're going to replace the y's with 2 and solve for x. And we expect that we'll get the same x value both times, and that will be our double check that we've solved this correctly. If we get different x values, then we did something wrong. We need to go back and check our solution for y. So the top equation becomes 3x. 2 times y becomes 2 times 2, so that's 4. So 3x plus 4 equals 1. We can subtract 4 from both sides. This gives us 3x equals negative 3. Divide both sides by 3, and we get x equals negative 1. Well, now we want to check that we get that same answer in the second equation. So we start with 3 times y, but y is 2, so 3 times 2 is 6, minus x equals 7. Subtract 6 from both sides, and we have negative x equals 1. And now we want to know what positive x is, so we divide both sides by negative 1, and we get x equals negative 1. We see that our answers for x match, so we can write our final solution to the system as an ordered pair, negative 1, comma 2. Okay, so this is the end of the video. Review this video tutorial. You can take notes and pause as needed. There are additional website videos with more problems if you want to see more worked out problems. After that, the next topic involves word problems. Once you've viewed all of those problems and videos, you can go on to the practice. And after you've completed the practice, check your work with the answer key. Once you feel confident with this topic, go on and complete the Section 2 quiz.